Okay, all right. I know some of you guys are still working, but let's get started on the first part. Okay, so let me just. I think this is the question I've got written. All right, and I just drew the thing directly on your notes. Okay, so we've got a PDF that looks like this. Okay, so it looks like a triangle. This is hard to do. Okay, so I want a line like this and a line like this. Okay, and what we have is that this is 0, 2. This is the only info that's given, but that should be enough, okay? Because what we know is that the area of a PDF equals 1, right? So it's a triangle, right? So so we know that this height has to be 1 here, okay? Because base times height, so 2 times 1 divided by 2 has to equal 1, right? So base times height times 1/2 must equal 1. Here we have 2, and we've got h, and 1/2 is equal to 1, then therefore the height is 1, and so we've got 1 up there. Okay, so with that, our PDF, our f of x, has to be 1 minus 1/2 x, right? So that when we're at 2, when we plug in 2 for x, we're going to be at 0. Okay, this part I think most of you guys got. Yeah? Okay, and then the next part, I think a lot of you got this, but some of you, I think, made a mistake here, okay? All right, and so what we want for the CDF is we want the integral, f of x, okay? And what you have to remember is you have to change from 0, you're going to go from 0 to x, or technically negative infinity to infinity. So technically our PDF is this, and it should be for 0 less than x less than 2, and then 0 elsewhere. That's technically the full PDF, okay? So that's our PDF. And so what we want to do is we want to go from 0 to x, okay, of 1 minus 1/2 x, I'm not x, sorry, 1/2 t dt, okay? So if you leave it in like x dx and then you go from 0 to 2, you're just going to get the area of the triangle, which is going to just be 1, okay? So that you don't want to do that. You want to make sure you're doing your CDF, which is going to be from 0 to x, right? Because what we want to do is that when we plug in 0, our CDF is going to be 0. And when we plug in 2, we want our CDF to be equal to 1, right? So these are just kind of, I guess, logic checks or common sense checks at the end, okay? Is that big F of 0 should be 0, and big F of 2 has to be 1, okay? Because we know that whatever the PDF is, it's going to enter 0, it's going to do something, okay? And then when x reaches 2, it has to be at 1, okay? So there's something. This is kind of the part that we're trying to figure out. So we're going to work on this, okay? And so when you take the integral, you're going to get t minus basically 1/2 divided by 2, so 1/4 t squared from 0 to x, okay? I guess I could have been mean and I could put a different number here where it didn't start at 0, okay? And you would also have to figure that out. Okay, so this is what we've got, and so we get x minus 1/4 x squared, and then minus everything here 0, so I don't really need to do that, okay? And then we're gonna just double check, okay? And we will, so this is my big F of x, okay? And then let's just plug in 0. And we get 0 minus 1/4 times 0 squared, and that indeed is 0. Okay, and then let's plug in 2, all right? And we get 2 minus 1/4 times 2 squared, which indeed is 2 minus 1 n equals 1, okay? So it looks like our f of x is okay. All right, so I was walking around, it looked like, I think quite a few of you got this, okay? Not everyone. I think almost everyone got this part. And then I saw a lot of people get this part, okay? Is this all right, the CDF? Okay, now we want the inverse CDF. Okay, so we want f inverse of x, okay? And what we want to do is we are going to take this, we're going to set f inverse of x, it's actually, I'm sorry, it should be f inverse of u, okay? Okay, sorry. So it's big F of x, and we have f inverse of u. And the way we're going to do this is we take our f of x, we set it equal to u, and then we solve for x, okay? Okay. All right, so how should we go about solving for x? Yeah, okay, so first we're going to multiply both sides by 4, okay? And we're going to get 4x minus x squared is equal to 4u, okay? And then, you know, I'm going to multiply by negative 4, actually, okay? This is what I'm going to do. Okay, so I got x squared minus 4x is equal to negative 4u, okay? So we're going to do this. All right, and this is, I think, so I think people made some mistakes here. F inverse of something is you don't do 1 over the function, okay? And then the other part is trying to solve for x here is a little bit tricky. You have to do probably a trick that you guys forgot, okay? And we are going to complete the square, okay? So I'm going to do x minus 2 times x minus 2, okay? And this is equivalent to x squared minus 4x plus 4, right? So I have to, I've effectively added 4 to both sides, okay? So I'm basically doing a plus 4 here, and I have to do a plus 4 here, okay? And so x minus 2 quantity squared is going to be 4 minus 4u. Is that right? Okay, and then so now I'm going to set x minus 2 equal to plus or minus the square root of 4 minus 4u. Is that all right? So I've got x minus 2 squared, and this is now x minus 2 is equal to plus or minus root 4 minus 4u. And now we'll bring the 2 over to the other side, okay? And then with this, I can factor out a 4, okay? So I've got 2 plus or minus 2 root 1 minus u. Okay, now we have to figure out, do I use the plus or do I use the minus? All right, so I'm going to go to the next page. This is just algebra, but it might be like algebra we haven't done in a while. So, all right, is everybody so far so good? Okay, so I've got x is equal to 2 plus or minus 2 times the square root of 1 minus u. Okay, all right, and so this is what we have, right? We've got this, okay? This is our PDF. And then we've got something like this for our CDF, okay? From 0 to 2 or something, okay? I mean, the exact shape of this doesn't really matter, okay? And what we want is basically, if I plug in something close to 0, okay, like what was the example I did? 0.05, okay? This should give me a value close to 0, okay? And when I plug in something like 0.99, okay, because we want to know like what value from our PDF, is bigger than 99% of all other values, that value should be close to 2. Okay. All right, and so the U can be anything between 0 and 1. Okay, and so if we look at this, all right, so if I have the plus, okay, if we do, if x is equal to 2 plus 2 root 1 minus u, okay, then this has output range basically 2 to 4, okay, and we don't want that, okay, because our the x's are limited from 0 to 2, okay, so has output range 2 to 4, which is not what we want. All right, so so we let x equal to 2 minus 2 square root 1 minus u. Okay, and this has output range 0 to 2. Okay. All right, so let's go ahead and just try these out. So if u equals 0.05, all right, we would expect a value close to 0. Okay, if we look at our CDF and we're doing inverse CDF, that means we're going to plug in 0.05 and we're going to get something out over here. So we're going to, x is going to be 2 minus 2 square root of 1 minus 0.05. So 2 minus 2 root 0.95, I don't know what that is. Square root of 0.95 times 2, what is that? It's like almost 2, but I don't know. Here's my calculator. Okay, so I got square root of 0.95, okay, and what is that? That is not helpful. Okay, 0.974, and we're going to multiply that by 2, and we get 1.95. And basically, then that means x is equal to 0.05. Okay, so if I do 2 minus that, 0.0506, if we want to be very precise. All right, if u equals 0.99, okay, then what do I have? I get 2 minus 2 times square root of 1 minus 0.99, 2 minus 2 root 0.01, so 2 minus 2 times 0.1, and I get 1.8. Okay, and that matches what we would expect for our values. Okay. Any questions on this? So yes.
So instead of completing this work, can you just use the quadratic formula to find x?
Yes, and I think you would arrive at the same thing, okay, with the quadratic equation. But again, you have to figure out whether to use the plus or the minus. Yeah. All right, and then just to kind of demonstrate that indeed this generates the values that you want according to the PDF that you asked for. I'll just do this very quickly in R. Okay. All right, so what do we have? Okay, so I guess, so you will do RUnif. We'll ask for 100,000 of these things, okay? And then our function, so I'll call this inverse CDF, is going to be a function of u, and what it will return is 2 minus 2 times the square root of 1 minus u. Is that right? That looks right to me. Okay, all right. So we'll just do inverse CDF of u. Okay, so we'll run that, we'll run that, we'll run that. And let's ask for a histogram of x with like 50 breaks. I'd say that looks pretty good. Here, we'll ask for a million. Yeah, even more so, right? And that looks just like the PDF that we wanted, going from 0 to 2. And now we've generated a bunch of random variables from this distribution. Okay, so with inverse CDF, okay, assuming you can find the CDF and assuming you can invert it, you can generate values from pretty much any distribution, and it doesn't have to be one of, you know, something from the exponential family or something like that. Okay. All right. Questions? Feel good? All right. Let me show. We might have discrete distributions. Okay. Okay, and so a discrete distribution will have a probability mass function, and here I'm going to just do this. All right, so we'll just keep it simple, and I'll say x can take on the values 1, 2, or 3 with probabilities 0.2, 0.5. Here, let's change it up. Okay, 0.2, 0.7, and 0.1. Okay, and let me just draw what our PMF looks like. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I got 0.1, 0.2, 3, 4, 5, 0.5, 0.6, 0.7. Okay, and we're going to be at 1, 2, and 3. Okay, and so my PMF looks like I've got a bar or a mass value right there. Or maybe not circles, should be dots. 0.7, 0.2, 0.1. Okay, so that's what we have. All right, what does my CDF look like? CDF, I've got, it's the cumulative distribution function. So this is basically the probability that x is less than or equal to x, okay? Yep, all right, so first I have to actually start off with anything less than 1 has a CDF of 0, okay? And then for values between 1 and but less than 2, we're going to go to 0.2. And then for values where x is between 2 and 3, but less than 3, 0.9. And for x greater than or equal to 3, we have a total probability of 1. All right, and so what does this look like? Looks like this. So I'm going to just go 0, 1, 2, 3, okay? And then this is a little tough. Switch to pencil. That's not. Right, I need like a light colored thing here. Okay, so this represents kind of the that's supposed to be a thin thin line there. Okay. All right, so below 1, we have a flat line right there. Okay, and then between 1 and 2, we're at a height of 0.2, and then between 2 and 3, we're at a height of 0.9. And then above 3, we have a height of 1. Okay, so it might look something like that. Okay. All right, is that okay for the CDF? All right, so how do we inverse the CDF? Okay, I'm going to write a piece of notation. It's going to look a little odd, but this is how the CDF, inverse CDF works, okay? So this is kind of our x, and now we've got okay, and all right, so the equation is that the inverse, okay, is going to be the minimum value of t such that the CDF of t is greater than or equal to the u that you plugged in. All right, so basically what that means, okay, is that if I generate u, if u is equal to, say, 0.14, what value should x produce, right? So 0.14 is like right here. Maybe I'll use like a slightly different color. Okay, so if I do 0.14, this comes in between here and here, okay? And so what value should x generate? So remember, so if you see the PMF, it's like, oh shoot, what did I do? So recall the PMF. This is maybe a tiny bit of cheating, but x can be 1, 2, or 3, and it's probability 0.2, 0.7, and 0.1. Okay. So if u is 0.14, what is the x that it becomes? It becomes 1. It becomes 1. All right. So how does that even work here, right? So what we want is what value, okay? So if we look at our CDF, we want the smallest value of basically x, or in this case t, all right, that produces an f of t that is at least as big as 0.14, right? So if we plug in 0.14, anything less than 1 is not going to work, okay? But if I plug in x, any value between 1 and 2, if I plug in any value between 1 and 2, then the CDF is 0.2, and that satisfies this inequality here, right? So for any t between any t which is between 1 and 2, f of t is equal to 0.2, which is bigger than or equal to 0.14. Okay, so any t between 1 and 2, I'm sorry, bigger than 1 but less than 2 is this, okay? And we want the minimum t. We want the smallest t that still qualifies, okay? Okay, which in this case is t equal to 1, all right? So f inverse of u equal to 0.14 is going to be 1. Is that right? Okay, and so the resulting inverse, okay, all right, so u can be any value between 0 and 1, and so what we have is that for u between 0 and 0.2, we're going to get 1, okay? As soon as u ends up being bigger than 0.2, okay, as long as it's less than or equal to 0.9, then x equal to 2 satisfies this inequality. And then lastly, if it's bigger than 0.9, okay, then x has to be 3, or t has to be 3 to satisfy this inequality. Okay, and so the inverse CDF, so this, this is a little bit maybe harder to, and it's not that hard to implement in R, but you can do it. And the inverse CDF will look like this. Okay, so between 0 and okay, so I got 1, 2, 3, 4, 5, 6, 7, 8, 9. Just okay. So 0.2, 3, 4, 5, 0.5, 0.9, and 1. Okay. So the output is that between 1 and 0.2, it's going to, or 0 and 0.2, it produces 1. Between 0.2 and 0.9, it produces 2. And between 0.9 and 1, it produces 3. Okay, and technically, I guess, no, that doesn't work. The CDF works that way, but the inverse does not. That's it. Okay. So that's inverse CDF method for the discrete distributions. All right. Is that good? Okay. I'll put up a homework soon. Okay. And in the homework, you're going to be generating values from different distributions, and one of the have you do some statistical tests, okay? To see if a distribution, or I should say not if a distribution, if a random sample comes from a distribution, I guess given distribution. All right. Did you guys learn how to do this? Or no? I don't know. Like, how do you test to see if a sample that you have comes from a particular distribution? Not necessarily the normal. So for the normal, you use what? Like QQ norm or something, right? Okay. No? We didn't learn this? We did? Did not? Maybe? Okay, well, all right. Have you learned the KS test? No? Okay, so this is, I'm assuming Russian. All right. Kolmogorov, Smirnov. All right. Test. All right. I don't know. Eastern European sounding names. I don't want to. I should look this up. Okay, so we got the KS test, or the Kolmogorov-Smirnov test. Okay, and it's a test to see if the observed data. Okay, test to see if observed data, or a given sample that you have, come from come from a given distribution. Can also be used if to see if two samples come from the same distribution. Okay, and the way it works is that we, all right, so I'll just write the big idea is that it computes so you'll have to read some of the help files to see how to run the KS test in R, but I'm just going to tell you how it kind of works. So it computes the empirical CDF of a sample, okay? And compares it to the theoretic CDF, okay? Or in the case if you're doing two samples, or another empirical CDF. Okay, so how does an empirical CDF work, right? Or do you guys know? So let's say we have generated the sample, okay? So I'm going to go ahead and, so just already in order, we have some sample. We're going to have 5 data points, okay? We're going to have 0.05, 0.1, 0.2, 0.6, 0.7. Okay, so I got five data points. Okay, so what is my empirical CDF? I'm going to just write this eCDF. Okay, so basically with 5 data points, we're going to say, okay, if x is less than 0.05, our kind of its quantile or percentile is 0, okay? And for anything between 0.5 and but less than 0.1, okay, our value, like a new value of x, is greater than 20% of the observations, okay? And then anything between 0.1 and less than 0.2 is greater than 2 out of the 5 is greater than 40% of the observations, right? And you go 0.2 is less than x, less than 0.6, and that's greater than 60%. 0.6 less than or equal to x, less than 0.7 is greater than 80%. And anything, if x comes in bigger than 0.7, we have an empirical CDF of 1. Okay? Because at 0.8, we'd be at the 100th percentile. Right? So it's basically what proportion of our sample has, values less than the given x. Okay, and so this will look like this, and we start at 0 and we go to 1.1. Okay, so this we're here, and then we jump up to 0.2, and then I don't know, where is it? 0.1, 2, 3, 4, 5, 6, 7. No, this is too much. Okay. 0.2, and then between, I don't know, where did it go? 0.2 and 0.6. 3, 4, 5, 6. It jumps up to 60%, and then 80%, and 100% right there. Okay. Something like that. Okay. Sorry, my graph isn't the best here. But so this is the empirical CDF based on the random data points that we have generated. Okay. And R can do this much faster for a much larger set. And then, and if you've got some kind of, like if you have a particular CDF or something, it's, let's say, basically, this is the empirical CDF, then you have the theoretic CDF, and R compares these two, okay? And it measures the distance between the empirical CDF and the theoretic CDF, and you don't have to worry about that just yet, but it's going to measure the distance, and it's going to spit back a value, okay? And basically, the null hypothesis in these tests is going to be data comes from given distribution, and then the alternative is data does not come from the distribution. So do you want a all right, so let's say you created a random number generator, right? A generator for random variables, and you want to see if it generates values from the exponential distribution, okay? So you generate a sample, and then inside the specifications for the KS test, which, we do ks.test. All right, and so here, the default okay, so you'll specify an actual CDF, okay, like p norm or something for your y, okay, and or p exponential. All right, and so if you want to see if your data, what you're hoping for is that your data is coming from, say, the exponential distribution. Do we want to see a large p-value or a small p-value here? Okay, what we're hoping for is that our sample comes from the exponential distribution. So we're going to do our sample versus p exponential, and we want to compare the two. So we want a large p-value or small p-value? We want a large p-value. We don't want to have any evidence that our sample is different from the exponential. Okay, so that's what you'll specify there. All right, we'll call that a day, and we'll see you guys on Wednesday.